I'm Grant Ingersoll, CTO, co-founder. I'm of Lucidworks. I'm also a Solar committer. I think I've met many of you over the years. This is a kind of a conceptual talk that I want to kind of give you some thought pieces around how I see search evolving into areas that perhaps many of you in the room haven't necessarily thought about in terms of how it relates to things like databases, data warehouses, et cetera. Unplanned, actually, it was really nice to hear during the keynote this morning that Ken from Bloomberg said, hey, you know, we're really starting to get interested in how these search engine things might be used for databases, how we might add things like transactions and all the kind of typical things that you see with database. And this has been something that's been on my mind for quite some time as well. And I'm kind of going to hedge a little bit here with this notion of at least search as a data warehouse, not a full-on like transactional database, like something you could actually run a bank on or things like that. And I'll also have you note there's a reason there's a question mark on the end here, right? And that is, I don't know if this is right. All right, I think there's some good and interesting properties that make for search as a data warehouse. I'm going to try to make that case for you, but I'm also going to talk about why I think it doesn't necessarily work, or at least it doesn't right now. So that's the basic premise of it. And the story actually begins with a clicker that doesn't work. So it begins with, maybe it's my slides that don't work. There we go. Begins with somebody who led me into this. It's one of our customers, I won't name names, but they're in the finance space. And they came to us way back when with a problem that they wanted to solve using our technology, Fusion. We'll give a little ad for Fusion. You guys can all hear the story later. But at the end of the day, the really interesting thing about this use case was that they wanted to replace Teradata. They wanted to replace Teradata, which is, of course, as many of you know, a really large, very popular data warehouse. And they wanted to replace it with us and use us to power a lot of really interesting data-driven insights, next best actions, as they like to call them, around how their wealth managers engage with their clientele. The really cool thing about this project early on was that I don't think even the first version had a search box in it. All right, this is all doing kind of traditional roll-ups, analysis of customers, all of that kind of stuff, right? So I was like, that's really interesting. You're going to use us as a data warehouse. And they said, yep, and away they went. Now, I mentioned Fusion. This is Fusion. I'm not going to spend too much time under there, but the really cool thing at the end of the day here is you've got Solr and Spark, and the reason why this stuff is interesting is I started really digging in on what is a data warehouse. Now, my very early career, I was actually an Oracle DBA, still recovering from that. Thankfully, I found search and found the light. And so I started to unpack kind of what goes into a data warehouse. So this is from Wikipedia, and this is just kind of a standard reference diagram. Anybody who's been in this space probably has built these kinds of things over the years, but basically data in, ETL, favorite thing of every engineer ever, store it in a database, do some massaging of it, pull out some things that you want to pull out into data marts, and then put a variety of front ends on it, typically around BI, et cetera. There's some important things to note here. You also have like metadata management, governance typically. Probably the biggest thing that you want to think about here is this is not your transactional system. These kinds of things are designed for 100 analysts, 1,000 analysts, kind of people whose job it is to dig in on what's happening across all those data sources. So you might have high write volume, but it's typically done in batches, at least in most cases, or at least traditionally. And it's often very low read volume, right? Everybody with me so far? So that's kind of some of the basic definition around data warehouse. So we'll get into it a little bit more deeply here in a minute, but I'm sure many of you in the audience are starting to think, okay, I can start to see where this is going. And so I did this as well. I started digging in on our customer base. Who else is doing this? Where they're literally abusing a search engine for what is essentially a BI analytics use case, a data warehousing use case. And sure enough, I started to unearth a number of them. One of the other highlights for me was actually one of our auto manufacturing clients who actually had us contribute back a whole bunch of capabilities to Solr to enable this use case and actually enable doing this use case in real time. So instead of having to have a whole bunch of predefined SQL statements around what questions you were going to ask of the data warehouse, the client, the user could actually do those things. So for instance, what they were doing is imagine taking the VIN number of your vehicle. We all know what that is. Now imagine rolling up all of the parts, where they were manufactured, all the recall information, quality information, warranty information, customer information, et cetera, and then being able to query that in real time in lots of different interesting ways, right? So if you've ever dug in on Solr's JSON faceting stuff, there's been some recent, probably about 2 years ago now, work in there around being able to do what effectively we call co-relational joins, being able to do not just parent-child, but grandparent, grandchild, cousins, those kinds of things. And that was all driven a lot by this use case, basically, of being able to use a search engine as an analytics warehouse. And again here, the really interesting thing for me was this was barely a search use case in the traditional sense of keywords and 10 blue links, but much more search engine driving BI tools and analysis. All right, so that really got me interested in this idea. And so as I dug deeper, I wanted to kind of lay out what are some of the hallmarks of data warehouses. For those of you who've been in the business for a while, you probably have built many of these. I'm also going to cover data lakes as well because they're kind of similar and I think have properties that might be of interest. And I think in many ways, the case I'm trying to make here is search can do this as well. So some of the hallmarks, right? At the end of the day, designed for those BI tools, the analytics, you're often dealing with lots of different data sources. Companies typically spend a lot of time as an IT department trying to figure out how to get all those data sources into a common place, figuring out schemas, figuring out how to not kill the transactional system, right? As they load this data in, these things are often very highly structured. And at the end of the day, they're geared around this notion of facts, dimensions, aggregations, right? And you put a SQL layer on it and you can go do your job. And at the end of the day, the big downside most business users complain about with data warehouses, or at least traditional data warehouses, is that they're really slow to change or to respond to changing needs of the business, right? Business will come and say, hey, I've got a new question I want to ask in my data. Oh, by the way, I need this data source, or I need this data in this format. And 6 months later, IT finally delivers on that project because they have to go through the whole, analysis, requirements. They realize that their star schema doesn't work anymore. They need different relationships. And then, of course, they have to optimize the queries, lather, rinse, repeat. Oh, by the way, by the time they actually deliver the question, the business has moved on, or the business realizes it wasn't the right question that they wanted to ask, and everybody's unhappy, right? I see a lot of nodding heads here, so this is, I'm pretty sure, resonates with a good number of folks, especially at large companies. On the data lake side, kind of similar ideas. The premise here is you take something like HDFS or some other distributed file system, S3, any of these large blob stores, and you basically throw everything in there. And instead of doing all the work around schemas and all of that kind of stuff, you just put it back on the user, and IT says, here you go. And then everybody goes in and tries to figure that out using typically kind of some of these schema on read tools like Dremel or Drill or Impala or those kinds of things. Typically, the users of these types of systems are in the machine learning space, some analytics. Frankly, the big failure of data lakes, I think, for most people is there was this promise that they're going to port all these applications onto the data lake, and then the data lake would magically solve these problems. But I think the reality is most businesses took so long to get the data lake up and running that, everybody continued to still work on their own silos, and then the business couldn't port the applications fast enough. And so what they often have these days is, for a large majority of users, it's just basically a data swamp, with the exception of typically, really high-end internet companies get a lot of values out of these, and your data scientists and the people who are, data natives, if you will, usually are pretty comfortable in these systems. But everyone else is like, why did we just spend all that money on that Hadoop cluster? Everybody with me so far? All right, good. So digging in a little bit more, what are some of the requirements? If we're going to make this case that a search engine like Solr can do this kind of stuff, what do we need to be able to support, right? So of course we need full SQL, right? Because that's the standard lingua franca of data warehouses and in fact many data things. So we need to be able to do joins and aggregations and grouping and math and stats, and we need to be able to plug in user-defined functions. And of course, these days, we wouldn't be complete without some machine learning in there as well. We need to be able to support schemas for a lot of different data types, right? It's not just rows and columns of numbers anymore, right? We've got to be able to have text in there, enumerated, categorical. Spatial is a huge part. We need to be able to store key values and blobs and all of that kind of stuff. And then, in order to make sure the business runs properly, we need security and data governance and ETL, and we need to work with all these tools that people are used to working with, right? So your Tableaus, your Power BIs, your Lookers, your Python, your Jupyter, all that kind of stuff, right? So this is kind of a baseline, I think. I'm sure there's other things you could think of. So let's really dig in on what's the case to be made here. And I'm actually going to start with the case against because I don't want to end on a sad note, right? We want to be happy. I want you to walk away, yes, I can do this, right? So the case against, like if you take and look at something like Solr or Elastic or Vespa or any of these open source search engines, there's a few things that kind of stand out as missing. First off, I don't know about you, but almost none of these have any notion of governance and MDM, those kinds of things built in. There are open source tools that help you do governance and MDM and that kind of stuff. And in fact, when I look at our customer base, we actually have customers who do MDM, master data management, out of Solr. So their MDM application is built on Solr, right? So that's an interesting one. So these aren't particularly hard to add. Most search engines don't necessarily do schema on read all that well, although that has been changing, especially as Lucene has added more capabilities around regular expressions, the finite state automaton stuff. So there's a lot more flexibility around schema on read where, hey, maybe you don't have to tokenize everything. You don't have to know every single field type going in. You can be a little bit more dynamic. But generally speaking, the search engines that I'm aware of typically want you to invest some time in saying, hey, this is a float, this is an integer, this is a geohash, those kinds of things. But you can get there. In fact, I've built Lucene-based applications way back in the day where I had to take in whatever was given to me, figure it out, try to do it at index time, but if I couldn't do it at index time, I would then punt it out to the user and let them do it. So sort of a schema on read. So you can get there. It may be slower than if you actually do know how to index, so it's still in your best interest to take the time to do it. But if you can't, you can still get away with it. Probably with some of the bigger things, though, I find is that most engineers don't necessarily know how to think in search. Now, you all, of course, are here, so of course you do. But a lot of people, especially if you've been trained on relational databases, things like tables and star schema and snowflakes, like we don't really talk about those things in search too much. but of course you can do those. We think about data modeling perhaps differently than databases. Again, they're not totally foreign concepts, but if I'm just coming in as a database developer and I start looking in the Solr documentation, it's not like I'm going to feel like I'm at home, right? And then, I think there's often just, a lack of training, lack of understanding on how to do this kind of work in a search engine, right? Like I said, we have a few customers who have done this, but it takes a lot of work to think about how you're going to go about doing that, right? Especially because out of the box, tools like Solr are geared towards kind of this top-end analysis or top-end retrieval problem, not necessarily large batch compute kinds of problems. Some other cases against, look, at the end of the day, I'm a computer scientist. Many of you are computer scientists. If you're not, it's the proverbial use a hammer to pound in a nail, use a screwdriver to screw in a screw, right? So use the data structures and the algorithms that are best meant for the kinds of problems you're trying to solve, right? And so there's a reason why relational databases exist. If you have relational data problems, use a relational database. They're very good at doing set operations, right? They're really good at rows and columns of numbers and those kinds of things, right? Other things, for instance, like Solr, Lucene aren't really good at dense vectors, right? So things like image data and audio data or things coming out of deep learning models like what Camelia was talking about this morning at the keynote, those aren't necessarily first-class citizens just yet. And then there's a variety of kind of other things. You can read the slides, but again, like have some common sense here and think about, can I actually make this work? Maybe do a quick prototype to test it and then go from there. You can do some things like S3 storage. There's a reason I have an asterisk on there is this is a Fusion feature as we do offer large blob store like storage. We build it on top of Solr, so you can make that kind of stuff work. I won't say it's to the same level as S3. Like you're not going to put a 5 petabyte key value type blob into Fusion, but you can do gigabytes certainly, and at least probably in the hundreds of gigabytes in there. A few other things like, look, we don't have a file system semantics, so if you want to do ls-l on the command line against Solr, that's not really a thing. Maybe someday somebody will add that, because I think that would be pretty cool. And then the other thing too is like, look, if you've already got a good production database or a good database in production, many of these databases now have search. I know this is heresy to say at a search conference focused on Solr, but many of them have good enough search, right? Like you can go to Postgres and you can do basic search operations, right? Are you going to get as good a relevance? Are you going to get all the knobs and dials that like a Lucene-based system offers? No. But you could probably do basic keyword lookups, those kinds of things. Same goes for tools like Mongo, and places like Cassandra have added Solr in, so you can often get what you need out of that. I don't know if I've missed any, but feel free to jump in. So let's go shift over to the case 4, right? And this is one of the really interesting things. Back when NoSQL was really big, I would say, oh, well, search has been NoSQL since before NoSQL was cool. And then now we're back to SQL, and most of the search engines now do offer some flavor of SQL. If you look at Vespa, for instance, its whole query language is SQL. Solr has some base level capabilities. I believe Elastic does too. Fusion's actually is a fully compliant engine. We do some really cool things in there with not only supporting SQL, but also supporting Solr query operators, right? So you can actually go way beyond the like query and the 3 operators that native SQL offers and do full-on, phrase queries, all that good stuff in the engine. Most of these support JDBC, ODBC, kind of all the standard connectors, which have then, like I mentioned earlier, unlocks all of your existing tools, right? Your Tableaus, your Power BIs, any database tool that can connect via one of those connectors and implements a standard dialect, you should be okay. Now, I say that, almost with quotes because almost all of these client tools of these have these little tweaks, these little specific dialects that sometimes will screw up even the most compliant engine, right? All of these engines out there now support joins, they support grouping, a lot of the roll-ups and aggregations. Most have moved beyond kind of this notion of just doing top N type things, right? So, especially in the Solr land, which I think is the best out there, the Solr streaming expressions give you a lot of capabilities around effectively doing in-index compute and roll-up operations like you would do in a data warehouse. So for instance, Joel Bernstein, I think, gave a talk last year on how he was integrating Apache Math. Apache Math basically unlocks stats, matrices, a whole bunch of things that any statistician, any data analyst would want to be able to do. And you can do it all right in the engine. If, God forbid, you're an Elastic user, there's some basic operations in there as well, like aggregations, etc. Digging in on that a little bit more, you can go read the documentation, but I mean, I've been in search a long time. The idea that I could do DSP or computational geometry or integrals or curve fitting in the search engine was kind of unheard of. We used to have to pull everything out, 10,000 rows at a time, 1,000,000 rows at a time, and then go try to make sense of them, right? Again, I would encourage you to go look at some of this stuff. But here's, for instance, a screen grab I got from Joel where he's basically running your kind of standard SQL statement. I think he's doing a regression on a bunch of data that he has in Solr, and then he's feeding out a visualization of that into, I forget what charts he's using there, but kind of all happening right in Solr, so no more having to pull all of this kind of stuff out, which is all really cool. And again, if I'm in the data warehouse land, these are things I'm doing all the time, right? Because I'm constantly trying to analyze data and figure out what are the relationships, etc. And then there's a number of other factors that I think go into this that are particularly compelling. Most of these engines have pretty tight integration with Spark. Spark kind of gets you to that next level of compute when it comes to this kind of stuff, right? So Solr and basically all the Lucene engines, et cetera, most search engines are really only good at, and although this is changing, doing kind of first and second pass operations. They're not yet full-on distributed compute kind of iterative style calculations, right? So this is where Spark often comes in, because Spark is actually pretty well designed for that iterative, convergent calculation that often goes into especially things like machine learning calculations. There's a simple one, for instance, like something like k-means clustering, where you have to iterate until you converge. That kind of thing you can-ish do in Solr, and I know there's been some work on that, but it's still not quite to the same level of Spark, where there's a lot of work that goes into how you load and move around data, what data to keep in memory, how to kind of share things across the cluster, all of that kind of stuff, right? You all know, though, at the end of the day, this is kind of bread and butter for this, for the folks in the room here. But these engines are scalable, fault tolerant, pretty flexible schema-wise. If you really dig in on Lucene underneath the hood, kind of one of the big innovations Lucene has made over the past 5-10 years is just really adding in all these different ways of storing data. That kind of percolates up to Solr as your field types, right? So, we've always kind of been the text field type, and then we added support for, column stores, and we added different ways of encoding really dense data, right? And these are all things that databases have been doing for a long, long time, right? So effectively, there's this idea where, the bigger picture is all of these data stores are trying to get at and recognizing that there's a lot of different ways people want to engage with the data, right? And there's kind of these latent factors underneath the hood that all these different engines are trying to help people understand, right? So databases have been adding search has been adding databases. You know, the basic premise here is you decide which one's better, right? At the end of the day, I think the real kicker for this stuff is when you have multi-structured data, which is let's face it, pretty much all data out there, right? Where you have text, where you have metadata, you have rows and columns, all of that kind of stuff, right? Little ad for Fusion. You know, I want to then map what we do in Fusion on here. Again, kind of really what started to seal the deal for me again here is if we go back to that Wikipedia picture, data sources, blah, 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 on through. This is how we think about it. We've got data sources. We try to do some smarts on ingest, but at the end of the day, we're putting it into a data store like Solr, and then we bring Spark in there. So you have Spark to do the large-scale offline processing and update the engine, and you've got ETL, and then we try to be smart on the relevance side, and then, oh, by the way, you can connect all your clients to us on the front end. Go see the booth if you want to talk to people on that. But here's the really cool thing, right? You still can do search, right? You can still do that ad hoc, fuzzy matching, querying. Text is a first-class data type. I often like to joke that the reason text is called unstructured data is because some Oracle salesman knew he couldn't handle text, and he wanted to give it a derogatory term. It's unstructured. You all know that text is the most structured data on the planet. Well, maybe images are, but text really, in a lot of ways, there's so much structure in text. It's called grammar, right? I mean, these are things you learned in the 3rd grade or whatever. It's just databases aren't very good at doing it, and we are really good at doing it. So now you have this engine that can not only do all the rows and do the text, but it can do the rows and numbers. But here's where it gets really interesting. To me, kind of where all this stuff is going is when you think about the next generation of engineers coming up, right? When you think about the types of data problems you're trying to solve, I would put forth that the large majority of them look like this in terms of SQL. So in the old days, you used to do select star from, where, sort by column A, sort by column B, sort by column C. You would load them up into your spreadsheet. You would probably create a pie chart off it to summarize the data. And then you would sit and spend your afternoon reading through rows and rows, and you would click the button at the top to say sort by date. No, sort by income, sort by this, and you would spend kind of your afternoon trying to figure this out. This is what a lot of data analysts do for a long period of time. There's still many people that work this way, right? Hell, this is how I look at my own personal finances all day, is load them up into a spreadsheet and then try to figure out what matters. That doesn't work anymore, right? Back then you had 1,000 rows. You spend an afternoon, you find the 3 that matter, and then you go about your way. Now you've got 1 billion rows, 2 billion rows. Some of our customers have 1 trillion rows. You need the engine to help tell you what's important, right? So my kind of thought piece for you is that search engines and this notion of importance is to next generation applications what sorting and databases were to last generation applications. This is why you see us as a company really pushing this idea of being able to build real working applications with workflows on top of a search engine. And so like when Ken from Bloomberg says, hey, we also want to add in other data operations, that just kind of makes my heart jump with joy, because there's a lot of really interesting things you can do when you start to think about building applications with a notion of importance embedded into them, right? So what is this idea of importance? I think many of you already intuitively know, just from a search ranking perspective, but there's actually a lot more that goes into it, is you really want to design out a system that is proactive, that is delivering relevant, related data, that it's timely, it's real time. This notion of it being personal, of novel, of diversity are really interesting. So for instance, like when Reddit was talking this morning at the panel of, you want to be able to showcase all of the different opinions, right, that people bring to the table. Those kinds of things are super important. You want it to be free from bias, right? And I don't necessarily mean like the big societal biases here, but some of even the simpler ones that you see in when you build data systems of, if you simply, and I would encourage all of you to go do this experiment on your site, just simply go twiddle number 1 and number 2 in your search results. More people will click number 1 than number 2, almost without fail across almost every application you will ever build. And it's simply because they believe you, right? The engine has said this one matters more. For some reason, you put it first for a reason. And so you can do these kinds of experimentation. And so kind of this notion here of free from bias is this engine, this notion of figuring out what your importance function is, should have the ability for you to understand those kinds of effects. And then of course, it should understand security and who's doing all of this kind of stuff. And most importantly, like it should learn over time, right? Relevance is no longer, kind of the 1970s information theory approach that still exists at Lucene in its very core of, things like TF, IDF, but instead where you basically had one model of relevance across all of your data, right? Now relevance really is, and this notion of importance really is per user, per query, per point in time, per data that's in the system at that. And it has really evolved. And so you have to think about how does this stuff learn and evolve over time. That's kind of the basic premise. I'll just leave you with one last one. This audience already knows it. This is a talk I've given some other places, but this really brought it home for me as one of our largest customers, basically using us for compliance and analytics. And again, there's barely text to be found in this application, right? Massive, massive data warehouse, all powered off of search, feeding not only people, but downstream machine learning applications and all of that good stuff. So, yeah, I'll leave it at that. Any questions? Stunned silence. Am I full of it? Anybody else doing this? All right, there's a few here. I'm not crazy. Awesome. There was a question there?
I was just going to make that observation that we are actually doing this, and in doing the warehouse piece, what we discovered was that when we actually recast the problem as a search problem, that the users thought about it the same way as we thought about it. So when we presented them with a different model, a lot of the problems they were trying to solve with the data warehouse, they realized that that was the wrong tool. So it wasn't that search, it wasn't that we had to recreate the tools that were in a data warehouse. It was when we gave them a different screwdriver or a hammer, when we gave them a screwdriver, they suddenly realized that they had a screw in front of them.
Yeah.
And so we got there were still some use cases which needed data warehouses, but most of it, 90% of it can be done with search. And it was a revelation, really.
Yeah, and I would even guess, I think I just got louder here, but I would even guess that if Lucene and Solr were to add a few more operators, that you could go full on and be 100%.
Maybe, but it was the difficult problem we had disappeared when we thought about it as a search problem. And it disappeared not just for the technical people, but for the users, the consumers of that data.
Well, and the other thing starts to happen that you realize is these search engines can keep up, right? So now all of a sudden you don't have to have this offline batch dump into the data warehouse. You just start flowing everything in there, right? It's just another sync off of the message queue or whatever. And now you have this native system that's in sync. And then the light bulb really goes off when the architect realizes, maybe I don't need that other one. And then that's the real shining moment, because what starts to happen, and you see this already, and this is the reason why I was being a little cheeky with the title, is I think you can even go further than being just data warehouse. And there's many situations where, look, just you could replace Cassandra, you could replace Mongo, you can replace any of those kinds of systems. These systems are certainly capable of handling full-on, I would say, near transactional loads. Again, am I going to run my banking business off the fact that, of what is an eventually consistent data store like Solr? No, but Most other applications, especially consumer facing, sure, why not? In fact, we have a lot of customers doing that. You see a lot of people in the community doing that. It is certainly a viable approach. Lucene is so good at churning data around these days and making it available that you're often talking milliseconds from write to being readable. So, any other questions? Not bad.
Yeah, so we had a similar ask about big data, and when I recommended Fusion, that was a cheaper solution actually. Turned out that it not only did the scaling well, but it was also cheaper for us. So that worked out for us. It was not a data warehouse, but it was more about big data. So.
Yeah, wink, wink, cough, cough. Like the Hadoop is overkill for a lot of people, and these big data solutions. Again, there's certain use cases for sure, but I've seen this repeatedly, right? And it was so, in some ways, if I put my business hat on, it was really frustrating back during the hype stage of all that, because I'm sitting here thinking, my God, I have all these use cases that show we can handle all these big data things, right? And you add in streaming, and we actually pre-Fusion had a big data product that was a combination of HBase and Solr. Some of you may remember this, total flop, right? Because we had all this baggage, frankly, from Hadoop. And none of our customers they're like, wait, are you just like trying to be a Hadoop vendor? And we're like, no, we're trying to do this really cool thing with search and large big data storage for large compute. And frankly, when we sat down to redesign Fusion, or when we designed Fusion back in 2013, we literally just said, well, what does HBase bring to the table that Solr doesn't have? And then vice versa. And it turns out there was like a 90% overlap. And so what we said is, well, let's just go fill the gap, that 10% that HBase provides that Solr doesn't. And we added that on top of Solr. And it turns out it was things like the key value store and a couple of other pieces. And then when Spark came along and gave us that large scale iterative compute, it was done deal. And that's been what's powering a lot of where we're at these days, right?
And we can merge it with the search platform.
Yeah. Exactly, and you still have search. And in fact, many of these systems, what's the first thing they do after they have basic indexing, read, write, and all that is they go add secondary indexing, which is search, right? So yeah, I mean, I think that's a dead-on observation. That's why I included data lakes in the space as well, but I think it can be a replacement of that. The other thing I've seen, and this is sometimes make the IT side of the house not happy, is it often takes way less people to run as well, right? So, then all of a sudden people get worried about their jobs, but in reality, they just get to do more interesting things. So, I think maybe one more question?
It's a little off topic, but you'd mentioned the addition of processes and workflows as a future capability to Lucene. Would you mind just clarifying what you meant by that?
No, I think in Fusion, this is something we think a lot about, right? So typically search applications have been read-only. Often, they're the secondary, they're not the primary store, right? I think a lot about, how do you kind of think about, most applications kind of have this workflow of show the user a bunch of results, the user picks one, they operate on it, they then update, right? Classic CRUD type stuff. Search engines can do a lot of that. So we think about how do we help you build those across both the back end and the front end, right? So that's obviously a little sales pitchy that goes beyond the data warehouse. But to me, this is that next generation of applications are going to be built off of the fact that everything is probabilistic. And so the sooner you start to get into your head that you're going to do read, write, CRUD on top of a probabilistic engine, the smarter your application is going to be faster, right? Because you have that ranking function, you have that learned ranking function in there. So if you start thinking that way now as an engineer, you're going to have a way more responsive, way more intuitive application than you did if you just kind of waited for every single release to update the results. I think maybe one last one here,
Yeah, you know.
and I'll repeat it.
I wanted to get on the implementation side of it because, maybe my understanding is that the suggestion is that you Solr cores each of those for one, let's say, okay, equivalent of a table or whatever in a data warehouse, and then use whatever ETL process that you use or similar thing to just as a tool to just do this, right?
Yeah.
Is it?
So the question was like, how do you actually model this out underneath the hood? And I think you know you're in the right ballpark that effectively a core equates to a table in a database. Although even that you don't have to do. There is, you know, we didn't. You know, I mentioned it somewhat in the downsides. You know, modeling out joins and tables and things like that takes a different mindset. Is probably the polite way of saying it, but it takes work to get that right, because of the way the indices are built so that those are efficient, right? So there is some work there around how do you model this. Sometimes you can do it all in, you can actually map multiple tables into a single index. Solr has gotten a lot better at going cross cores. This is where Spark also brings a lot to the table. In fact, our SQL layer is Spark, and then almost all of what we do in our Spark layer is hook into Solr Extreme. We hook into the query planner for Spark SQL, and we try to figure out and intercept and then push down to Solr streaming expressions, right? So something like select count by table in SQL, if you just did that the dumb way in Spark, it would go and have to roll up everything up into memory in Spark and all that. Well, everybody in the room here is saying, well, duh, that's just a facet, right? And so we intercept things like that and push them down and just do the appropriate Solr query underneath the hood where we can. And so our worst case will be we fall back to having to materialize into memory in Spark. But our best case is we can often push down into Solr because Solr is quite capable of those things. So yeah, there's a lot of different ways to model your actual tables and relationships. So there is work that needs to be done there, for sure. That's getting a lot more flexible in Solr with the streaming expressions than it used to be. But yeah, no, that's a great observation. So other than that, thank you very much and enjoy the rest of the conference.